Hello, last of the series tests. Woo woo! So, I actually saved the best for last, and this is the alternating series test. And honestly, it's one of the easiest one of them all, which is great. And you're probably thinking, why didn't you just tell us this first? Well, because it only works for alternating series. What's an alternating series? One that goes positive, negative, positive, negative, positive, negative. That's an alternating series. So if we want to do an alternating series test, I first have to make sure it's alternating, positive, negative, and then it has to satisfy two conditions. The terms of the series have to approach zero and decrease, okay? And they have to decrease going down. So it can't like go up and then down and then up more and then down and then up and then down. It's got to just be continuously decreasing in absolute value and head towards zero. If it does that, it converges. If it doesn't do that, it diverges. This isn't one of those tests where it's like iffy. It's either converge, diverge, nothing else in between. So, long story short, if a series alternates as its terms approach zero, then it converges. If that doesn't happen, then it diverges. End of story, done. So if we come down here and I say, let me think about this one. Does the series converge or diverge? As soon as you see this negative something to a power, you know it's going to alternate. Okay, but make sure the power isn't like to the 2n or to the 2n minus 1, because if it is, that means it's always odd or always even. So I shouldn't say negative something to a power. I should say when you have a negative raised to a power, but you know it's going to alternate positive, negative, then it's an alternating series. And if you're thinking, Ms. I don't understand this enough to know that, write out a couple of terms. When n equals 2, this is going to be 1 over ln 2. When n equals 3, it's negative 1 over ln 3, positive 1 over ln 4, negative 1 over ln 5. Yeah, okay, that alternates. Now, as we move along, my denominator is growing, which means the value of the fraction is shrinking, and it is going to the 0. The limit as n approaches infinity of the absolute value of the terms is most definitely 0. So since it alternates and the terms go to 0, this converges. Okay, and now if I look at this other one, this alternates. So if n equals 1, I have negative 2 over 1. When n equals 2, that's going to be positive 4 over 2. When n equals 3, that's going to be negative 8 over 3. And of course, OneNote is doing that thing again. Come on. So if we look at that, yeah, that definitely alternates. Are the terms shrinking? Well, the bottom is getting bigger, but the top is getting a lot bigger than the bottom. These terms don't approach 0. Therefore, this diverges. And one more thing you need to know, we know how I said we named that harmonic, the harmonic diverges. The alternating harmonic, on the other hand, converges because it's 1 minus a half plus a third minus a fourth plus a fifth minus a sixth. Since the alternating harmonic is, alternating and going to 0, pardon me, then I know it has to converge. And you might be thinking, wait a second, if the harmonic diverged, how can the alternating harmonic converge? Well, because here's what happens. If we think about the harmonic, the regular one, if I were to write out the decimal expansion, this is 1 plus 0.5 plus 0.3 repeating plus 0.25 plus 0.20 plus 0.16 repeating. When I add these together, all these decimals are pretty close. So I'm adding 10 decimals that are less than 1/10. Not less than 10 decimal values up to 1/10. That's definitely going to add up to a lot. And then if you think of all the decimals leading up to like 1/100th, I have 100 fractions leading up to 1/100th. These are going to add up to a lot. Okay? Every time we add up these fractions, they're going to grow and grow and grow because they're actually really close together. Like if I asked you how far apart are 1/1 millionth, is that a millionth? And 1/1 millionth and 1, those are practically the same value and they're next to each other. So adding them together like duplicates them. Well, that works to our disadvantage on convergence for the regular harmonic, but it works to our advantage in the alternating harmonic because as soon as I put a minus on every other term, I'm now taking some of that duplication away, and it's almost like the following term counteracts the term you just added. So every time you add these together, they're really starting to reduce. And so the alternating harmonic converges because, in a lot of ways, your terms practically cancel each other out. If nothing that I just said made much sense to you, just know the harmonic diverges and the alternating harmonic converges. We have done all of the tests that we are required to do. Now you get to go on and practice some things. So good luck. Let me know if you have questions.